For today's video, we will talk about the triangle congruence. Here are the objectives of this video. At the end of the video, the viewers should be able to differentiate postulates on triangle congruence and use the different postulates in proving congruency of two triangles. But when can we say that the two triangles are congruent? Do you have any idea in your mind? Two triangles are said to be congruent if and only if three pairs of corresponding sides are congruent and three pairs of corresponding angles are also congruent. But do you know that there is an easy way to determine if two triangles are congruent? Yes, it is with the help of the triangle congruence postulate. And what is that? Here is teacher David Lavay Jr. to discuss the different postulates on triangle congruence.
Hello everyone! So for today's tutorial, we will talk about postulates on triangle congruence. So we will start with side-side-side congruence, or what they call SSS congruence. So this postulate states that if we have two triangles, let's say this is the first triangle ABC and this is the second triangle DEF, and if this side of a triangle AB is congruent to DE, and if this side BC is congruent to EF, and this side AC of first triangle is congruent to DF of the second triangle, therefore these two triangles are congruent by side-side-side congruence. Moving on, the next postulate in triangle congruence is the side-angle-side congruence, or simply known as SAS congruence. So this postulate states that if we have two triangles, let's say the first triangle is ABC and the second triangle is DEF, and let's say side AB is congruent to side DE and side BC is congruent to side EF, and their included angles are also congruent, which is angle B and angle E. Therefore, these two triangles are congruent. The third postulate on triangle congruence is the angle-side angle congruence, or simply known as ASA or ASA congruence. So this postulate states that if we have two triangles, let's say the first triangle is triangle PQR and the second triangle is the triangle XYZ. So if angle P is congruent to angle X and angle Q is congruent to angle Y, and the included side of this first triangle, which is PQ, is congruent to the included side of this second triangle, which is the XY, then these two triangles are congruent. The fourth postulate on triangle congruence is the angle-angle-side congruence, or simply known as AAS congruence. So this postulate states that if we have two triangles, let's say the first triangle is the triangle LMN and the second triangle is the triangle OPQ, and if angle L is congruent to angle O and angle M is congruent to angle P, and the non-included side of this first triangle, which is LN, is congruent to non-included side of the second triangle, which is the OQ, then these two triangles are congruent. The last postulate on triangle congruence is the hypotenuse leg congruence, or the HL congruence. Now, this postulate is special in a way that we are only referring for the right triangle. When we say right triangle, it is a triangle in which one of its interior angle measures exactly 90 degree. Okay? So, this postulate states that if we have two right triangles, let's say the first triangle is triangle ABC, and the second triangle is the triangle XYZ. Now, if the hypotenuse of this first triangle, which is AC, is congruent to the hypotenuse of the second right triangle, which is XY, and one of its leg, let's say AB, is congruent to one of the leg of the second right triangle, which is the XY, then these two triangles are congruent. Let us have an example of the use of triangle congruence postulates in proving. For example, using this illustration, let's prove that triangle ABC is congruent to triangle DCB. So it is given that segment AB is congruent to segment DC. And also segment AC is congruent to segment DB. So let's use two column proof to prove that those two triangles are congruent. So we will put on the first and second one the given. So segment AB is congruent to segment DC, and also AC is congruent to segment DB. So our reason for this is given, since it is given. Now, the two sides of these two triangles are already congruent. And by reflexive property, we know that segment BC is congruent to segment CB since it is the common sides of the two triangles. So, segment BC is congruent to segment CB by reflexive property. Therefore, these two triangles, so the triangle ABC is congruent to triangle DCB by SSS congruence. SSS.
Now, it is easy for you to determine if two triangles are congruent. Postulates on triangle congruence are really a big help. According to Jones, Keith, Taro, Miyazaki, and Mikio, in their article about learning congruency-based proofs in geometry, congruence and triangle congruence in particular is generally taken to be a key topic in school geometry. This is because the conditions of congruent triangles are very useful in proving geometrical theorems, and also because triangle congruence leads on to the idea of mathematical similarity via similar triangles. In the real world, congruent triangles are used in construction when we need to reinforce structures so that they are strong and stable and do not bend or buckle in strong winds or when under load. That will be all for our today's video. Thank you for watching. See you on our next video.